Now, OSPF is one protocol, there is no doubt, but it uses different packet types to convey some information, special information. Not all informations are route update, right? So we got different type of information, like uh, if you want to guarantee the delivery, uh, you need an acknowledgement. Acknowledgement is one information. And if there is any clarification needed, then we call this query. When someone clarifies the doubt, when someone answers the query, we call it as update. You know, even to form neighbor, the ping messages are sent, we call it as hello. You see, we got different types of messages. In another word, we have different type of packets. OSPF packet types are 5 types. And this number that you see here, for example, 3, is a link state request, LSR. Now this number is not simply one sequence number, it's a number tied with this message type. If the message type is a link state request, then it is type number 3. So hello type, database description, LSR, LSU, and LSAC. LSAC is different from LSA. LSA simply means a link state advertisement. This is link state acknowledgement, LSAC. Do you have any question? Now, yeah, why not? Anything you can use. You can use simply debug command to see all this. Or you can use Wireshark. That will be much better. Wireshark is more than enough. You can use debug command to see DBD, LSR, LSU, LSAC, hello. But to see inside that DBD, you need Wireshark. In debug, you will see only, debug will show you only the type 3, LSR. But what is going inside LSR, you cannot see in debug. You can only see in some tools like Wireshark. In my previous class videos, I used to use GNS3 to teach, where I have shown in the video all those packets. Okay, so I'll also try to do it in your class once my GNS3 is installed. Right now I don't have. Any other question? Debug I can show today. All right, let's go next. You see, in the layer 3 header, we have protocol field. In the protocol field, you see OSPF. If it is OSPF packet. In the OSPF packet layer 3 header, on the protocol field, you will see protocol ID number 89, which is OSPF, and you can see these fields inside that one protocol field. Fields like version number, type, packet length, route ID, area ID, checksum, authentication type, authentication password, string in the data. This is the structure. This is how it is arranged, version number. Even in debug, you can see this. For example, I'll show you here a debug. You see, this is a debug of OSPF packet. This is exactly what you saw there. What is the version number you see there? It's a received packet. And the type. Type 1 means what? Hello packet. What happened? We just saw that. Hello. 1 is type hello. 3 means LSR. I told you. 5 means hack. So you can see type as 1, which means this is a hello packet. And the length of the packet is 48 bit. 48 byte, 48 byte. And the router ID of this router which is sending this packet is 10.0.0.12. And the area ID is 1, area number 1. Checksum is for the integrity. If someone breaks the packet in the middle, you will know. Authentication is type 0, meaning null authentication. There are 3 types of authentication, 0, 1, and 2. 0 is no authentication or null authentication. 1 is clear text or plain text. 2 is MD5 or SHA. Now, there is no authentication key because the authentication is null authentication. And the interface via which you received this is serial 0002. This is a debug. Okay. Now going back to this. If you see these fields, they are just same like what you saw in the debug. You see? Yeah. You see 2. I just showed you a debug, no? Version 2. Type is 1. Length was 48 bytes. Router ID was some IP address. Area ID was 0.0.0.1, which is area 1. Checksum some value. Authentication type 0. Authentication key nothing. Data nothing. Okay. Now, when you capture a hello packet, these are all the info you can see inside a hello packet. You see, without hello packet, neighbors cannot be discovered. The parameter that has got the marking, the star, like area ID has got star. Hello and dead interval has got star. Authentication password stub area flag has got star. These things must match with the neighbor. Router ID should not match, isn't it? Router ID should be unique for each router. It should not match. It should not be same with 2 routers, then confusion. 2%. Yes. 2% with the same face. It's very difficult to identify, no? 2% having same face. One guy says, I'll take you for dinner. And now You don't know which guy is that one guy who promised you to take you for a dinner. Two guys have got same face. Confusion. You are hungry. Dinner time has come. But these two guys are roaming around here and there. No one is coming to pick you. Same face. Difficult to go and ask them to take you for a dinner. So if two router have got same router ID, then we will not know who gave you this info route information. Confusion. Router ID should not be same. But area ID must match to form neighbor. Any router sending different area ID cannot be my neighbor. Timer also must match. Hmm. No. Hold on. What virtual link? When did I say virtual link? From where you got this idea? Let me draw what you said. Let me draw it first. You got area 10, area 40. And you got area 0. Okay. So here, these are all area 10 links. Here, it's area 0 link. Now, where is the virtual link coming here? Whatever this guy has got will be given to this area by this ABR. Only an ABR can take the route from area 10 and give it to area 0. There is no special command to configure a router as an ABR. Whenever you have one link at least, only one link, at least one link in area 0. If you have at least one link in area 0, then that router will be considered as ABR. It will automatically distribute the route of area 10 to area 0. Likewise, area 0 will give the routes to all other area like 40. That's how this A dot B dot C dot D is learned on this router here. Now, where is the virtual link coming into picture for you? That is different story. We have not gone to that side. Then you need a virtual link because area 40 is coming in between 50 and area 0. If area 50 don't have connection to area 0, then area 50 will not have ABR. ABR is not a router simply between borders. See, if I have one router here and have area 50, this is not ABR. To be an ABR, it needs a connection to area 0. That is why you need a virtual link between these two routers so that this area 40, sorry, not area 40. We said area 50 now. Area 50 is connecting to area. So that area 50 can have connection to area 0. For that, area 40 should simulate a wire, which you call it as virtual link. Okay, now why you bring virtual link in this topic? I don't know. We are talking about hollow packet. Okay, anyway, ask your question one more time. No, no. Neighborship will form between 50 and 0, area 0. Not with this route. Neighborship will not be formed with 40 route, area 40 route. This physical wire that you connect, this end is also area 40, this end is also area 40. They will form neighbor. But on behalf of area 50, there won't be any neighborship with area 40. Via the virtual link, via the virtual link, area 50 will form neighbor only with area 0. Right. Fine. When we go to virtual link, we'll talk about that. Those things are coming later. Now, this shows how the neighborship is established. You see, there are two routers, A and B. For the first time, OSPF is configured on router A, router A. Router A, first time we have configured OSPF in router A. And then B is still not ready. You have just logged into B. So during this time, A will be sending a hello packet. See, A is sending a hello packet to a multicast address 224.0.0.5 multicast address, putting its own router ID. Hey, my router ID is this. Because there is no other IP address, it is using the physical interface address. Usually the router ID will be the loopback interface address. When you don't configure the router ID, it will use the loopback interface address. But if you don't configure loopback interface also, if you don't configure loopback interface, then it is going to be physical interface. When you don't have router ID, when you don't have loopback interface, physical. So it sends a hello packet with its own router ID, which is what called as init state. You know what is init? Initiating. It is the initiating state. What initiation? What initialization? It is trying to initialize the neighborship, initiate the neighborship. Now B router from the hello packet, as soon as the OSPF is configured, B router learns about this router A. So B router, when it receives the hello packet, so far B router has not sent any hello packet. B has just got configured. As soon as you hit configure, hit the button, it got an hello packet with 172.16.5.1. So now B knows that there is someone called 172.16.5.1. Now B wants to send the hello packet. In the hello packet, if you notice here, the neighbors So now what happened? Router B, when it sent a hello packet to same, it is sending its neighbor. Router B sends hello, not just with the router ID, even with the neighbors it has already learned. Now, when this is received on router A understands that router B already know me. And router A now knows about B from this incoming hello packet, which means he knows me, Bala knows me, I also know Bala, which means two-way relationship. Two-way relationship. I also know him now. He already knows me because I can see my name in the hello packet that he sent. So from down it went to init. From init now it has gone to two-way. Two-way means they know each other at least by a name, at least by the router ID. They know each other. And now you see the wire name is Ethernet 0. If it is Ethernet 0, it is considered as LAN. I told you in the previous class. More day knowledge on those things is coming later. But if it is not serial port, if it is an Ethernet port, then there will be an election to select a designated router. If it is a serial port, then also there will be an election, but that election is temporary. We call it as master-slave election. So here they are not discussing more deep about those election like master-slave or DR-BDR, because here they are trying to explain you different states, that's all. But what actually happens in the start state is a router will be elected as a master, another router will be slave if it is point-to-point serial link. If it is multi-point broadcast link, LAN link like Ethernet, please let me see. I was about to say that and you are immediately, it's not fair. Wait for me to complete the statement. I have to repeat now again from the beginning. In the start state, there is an election. Between these two routers, one router will say, I'm a master. Another will say, I'm a slave. Now, this master slave is only for serial WAN link neighbors. If there is a serial wire, if it is a WAN link, one will be elected as master, another will be elected as slave. But in our case here, it is not serial, it's Ethernet, it's a LAN link, it's a broadcast link. So one router will be elected as a DR, and the other one will be elected as a BDR. And if you have much more routers, like 3-4 routers, then third and fourth router will be DR others. More on these things will come later. As of now, what I want to say is, in the start state, either master slave will be elected. For that, the link need to be a point-to-point serial link, or DR-BDR will be elected in the start state if it is a LAN link, Ethernet link. It can be fast Ethernet or gig Ethernet or 10 gig Ethernet or normal simple Ethernet. So DR-BDR is elected in the start state. Why it is called as extart state? You see, the next state is called exchange state. In order to go to this exchange state, to exchange the DBD, to exchange the database description called LSDB, link state database, one should be a master or a DR, and the other should be a slave or DR other. So before the exchange start, that's why it's called as extart. Before the exchange start, exchange start. Before the exchange start, they need to agree on who will be the master or DR. Only the DR can exchange. Only the master can. See, this guy says, no, you don't send me. This guy says, I will send, please. Now, this guy says, no, my router ID is big. I am DR. Yeah. So, this router is taking the leadership. I will start the exchange. Later you can continue. So DR is the one which is going to take this exchanging start. The first packet to exchange will be from the DR. You see, so one will start the exchange, the other will follow. If it is not an Ethernet LAN segment, then you will have a serial wire. In that, the one with the bigger router ID, higher router ID will be the master. So master will initiate the exchange. So that decision making, who will start the exchange, is taken in this extart state. Who will start the exchange? And now the exchange starts in the exchange state. Only the decision is made in the extart state. According to the decision made, the exchange starts here. This starts exchanging. DBD means database description. What is DBD? It is the summary of LSDB. That is what called as DBD. We know what is LSDB. LSDB is collection of all LSAs. All LSAs are put together. That is DBD. That is LSDB. Now, instead of sending the complete LSDB, it sends only the DBD. It sends only the summary of it. So, why it is sending the summary only? With the summary, the receiving router can easily make out the complete LSDB. You no need to tell the complete story. You just send the summary. I'll understand. That is how OSPF works. Advantage is the bandwidth will not be much consumed. CPU will not be much consumed to process when it is received. So OSPF is designed to only send the summary. If you are going to meet someone very busy man, you may have big problem, but you cannot say the entire problem taking 1 hour. because the busy man will not have the time to listen to you. So you need to try to keep it as small as possible. And if he has got some doubts, then he will ask you. He wants to help you. That's why he has called you when you have the problem. So instead of telling the big problem story, try to keep it short and tell him that is what DBD. Your problem is like LSDB, but keep it short. DBD. So here, both the routers share DBD. First, who initiated? The one with the bigger router ID, the DR. Or if it is point to point, the master. I told you, if they have any doubt, they will ask you. See, they are asking. But before that, after exchanging the DBD, they send the acknowledgement, ls ACK. You are asking, no, can you show these 5 types of packet? See here. This is how you will see even in the Wireshark. I'll show you in Wireshark also. Even in debug also you can see. This is the order. After DBD, what comes? LSAC. You should expect type 5 packet. After type 3, what is DBD? Type 2. After type 2 comes type 5, acknowledgement. And now, type 5 is acknowledgement, my friend. After DBD, after 2 is 5. Hello. What is sent here in the exchange state? What is sent here in the exchange state? My friend, what is the name written there? DBD, no? It is type 2, no? After DBD, what is going here? What type it is? నేను చెప్పింది అదే కదా. Right. After type 2 is type 5. Okay. After this, you see they got some query. Because they were only sharing the DBD, there is a query. Hey, I want more information about this particular network. Can you give? That is what called as LSR, link state request, which is type 3. For that, a response is coming, which is type 4. And for this, an acknowledgement is sent again. So in short, what I want to say is acknowledgement will be sent for DBD, for LSR, for LSU, for everything. For hello packets, there won't be acknowledgement. For hello packets, there is no acknowledgement. But for all other packets, acknowledgement will be sent. You understood? Did you understand LSR, LSU? Because they are sharing only DBD, they may get some queries to clarify their doubts. Then that queries are sent as LSR, link state request type 3, for which the router, the neighbor router, responds with detailed complete information of that query, LSU, link state update. And an acknowledgement will be sent once the update is received. Any question? So from down state, it moved to which state? After a need state comes what? After two-way comes what? X start. Correct. After X start comes what? After exchange comes what? After loading comes what? Meaning they don't have any more doubt, they're fully synchronized. They got identical database. Make sense? Now, within an area, they will have full state, they will have identical database with DR and BDR if it is LAN, if it is WAN with both. We'll talk in depth about this later, but I'm just telling you now, even if you understand, I'm happy. If you don't understand also, don't worry. Let me repeat. Within an area, with DR, BDR, and with the master routers, all router will have full state, identical database. Okay, now, sometime, this is an Indian interview question. I'm going to tell you what it is. What if the neighborship gets stuck in the extort state? This is actually an internet question. If it is, no. Answer is not that. What if, whenever you check show IP OSPF neighbor, it is not going to two-way state, it is not going to full state. It is simply stuck in extort state. What might be the problem? The answer is MTU mismatch. What? MTU mismatch. This was a very, very important question once upon a time in all Indian interviews. I don't know how that became very popular. It's not that important actually. Now, see, only if you go and make MTU changes, there will be mismatch. Otherwise, the default MTU will be well and good. There won't be a problem. Why are you playing with MTU? If you have some tunneling technologies like GRE, VXLAN, then you may try to do some changes to MTU. But on those days, not much tunneling techniques. But today, if you ask, yes, we do some lot of tunneling techniques, then MTU matters. But even though we do a lot of tunneling techniques, we configure MTU the same thing on either side. Whoever does that MTU change, they have at least small knowledge when they change. They don't change only on one side. They will change immediately on the other side also. There won't be problem at all. So that's why I said it's not that important question. Now, you see, there are two type of addresses, the multicast addresses, OSPF in a LAN environment needs. In a LAN environment, these two addresses are needed. Why? See, this is a LAN. If someone is drawing like this, it means it's a switch. It's a layer 2 switch. What does that mean? The IP address here will be 10.0.0.1, and here also will be same 10.0.0, maybe 2. Here 10.0.0.3. So they're all same network. Means they are all connected to one single broadcast domain. They are all in single VLAN. They are all connected to one single switch. So whenever you connect to a LAN cable like Ethernet, even if you don't have four routers, even if you just got two routers connected through Ethernet, there is going to be a DR-BDR election. We'll talk about that later, but still I want to touch a little bit of DR-BDR, but there's a special time and topic waiting for why DR-BDR, how DR-BDR later. Now you see one router is already elected as designated router because of bigger router ID or bigger priority, and parallelly the BDR will also be elected. They are not showing this picture, so I'm also not going to talk now. Later we'll talk. What I'm trying to show here in this page, why to address and how it is used. You see, whenever there is a change, the change should be notified to DR only. For example, you are writing exam. You are writing exam in school in Andhra Pradesh, India. I don't know about US, so I don't know about your Canada or US. So I'm a poor guy in India. So let me tell you an India example. So in India, you're a poor guy in America. I'm a poor guy in India. Both are poor only. Don't worry. Only the country is different. Now in exam in India, you're in the exam hall. They will the teacher will say, listen carefully. If anyone do giraffe, what is giraffe? Giraffe has got a big neck, looking into others' paper. That is what giraffe means. In India, teachers don't have that big a knowledge and all. They won't use giraffe and all. They will say, if anyone is looking into others' paper or talking to someone, you will be sent out. Any problem, you talk to me. That is what they will say. Any problem, you talk to me. You are not supposed to have full adjacency with your neighbor. I am the DR. Sorry. So teacher is the DR. All should have full adjacency only with the DR. Meaning what? They should convey only everything. They should convey only to the teacher. Now, you are here. The great Bala. Great Bala found one question out of syllabus. Sometimes some teacher does that. They don't have brain. And they simply copy the old question paper and form new question paper. They don't have their own brain. They won't set their own question paper. When they copy, they don't. They really did not see. They did not even read. They simply copied that question from the old question paper, which is set by some teacher who left the school, and printed for you. And you found that. Now you should not tell to others. You should not tell to others because you don't have full adjacency. You just got two adjacency. What does that mean? He is my classmate. His name is Lokesh. I'm Bala. He is Lavanya. I am Bala. That's all you should have. If there is any change in the question, already teacher told, you should only talk to me. Now the teacher will change the question and give new question instead of that out of syllabus question. So now, how will you, when you send a packet, how will you send exactly to DR? When you send anything to this address, only DR can receive it. No one else can receive it. It is like a word teacher. Teacher! Immediately teacher turns. And you tell the message. And student! Teacher will say that is like 224.0.0.5. All students will be paying attention. And now teacher will give a new question. The question is, what is your name after 10 years? It's going to be same only. So they will all write the same name, their own name, and get good mark. Anyway, happy teacher, happy question. Now, what I'm trying to say here is, to talk to everyone, this is the address that DR will use. And everyone to talk to DR only, they use the magic word teacher, 224006. So only teacher can listen to that. No one else can listen because they are not teacher. That is why here it is written, Router A notifies all OSPF DRs. It means all OSPF DR. What does it mean? DR and BDR. That is why it is all. Both DR and BDR with this address. Now, BDR cannot speak to anyone. Only DR will notify to others using file. DR will not notify BDR because BDR already know it. Okay, so more about these things are coming again later. We'll